Sensation and perception, that's what chapter 3 covers. And basically the question that we're discussing this week is, how do you know that what you see is really there? As stated by one of your classmates on the discussion board, and a quote that I heard all throughout grad school, is one's perception is one's reality. What does that exactly mean? Hopefully by the end of this PowerPoint or the end of your readings, you will understand that better, that what I perceive, we might be looking at, receiving the same visual information, but we might walk away with completely different perceptions, and thus my perception forms the basis of my reality. We have to talk about the enduring issues. The first is person and situation. To what extent do our perceptual experiences accurately reflect what is in the outside world? So when I experience something, how accurate is that experience with what's actually happening? So how close is my perception to the reality? Does it reflect me, you, or what's actually happening? Does it reflect the differences between us? The next two walk hand in hand: nature versus nurture, or heredity versus environment, and stability versus change. In what ways do our experiences of the outside world change as a result of experience over the course of our lives? So we talked about neuroplasticity and within chapter 2, and when you talked about that, we talked about how neural pathways are created through experience, and that experience essentially is building block. So if you think about it within that context, in what ways do our experiences of the outside world then change? So as a baby, if I saw the color white, maybe I was fine with it. But as we saw in the case of little Albert, that we're going to talk about more when we get to the learning unit, but was referenced in chapter 1, by the time he was a year old, he was greatly afraid of the color white, of anything fuzzy, too. So his experiences of the outside world, of external stimuli, changed as a result of experience. In addition, you have to look at, as I developed and I begin to expect of the outside world, if I push this button, this will happen. My son's at the age where he pushes buttons expecting a sound or expecting an action. Do these expectations come true? If I expect this of a student in my class, does that expectation come true? We will learn that while sensory information might be the same, our perception is based on us. So, diversity versus universality. To what extent do people around the world perceive events in the same way? You have two women, it appears on your screen. They're both engaging in what looks like cooking. To what extent, when consuming the food that they made, does the food taste the same? Do they perceive things the same? Do they perceive the experience the same? To what extent do we have universal experiences and universal sensation and universal perception? I failed to mention on the last screen that at the end we're going to highlight how individuals have different experiences based on a variety of personal factors. You're going to discuss this in the discussion board. We got to remember neuroplasticity. If neural pathways are similar, are then expectations similar? We also have to talk about mind and body. There's so much. You're going to continue to learn about the biological basis of behavior, essentially, in this chapter. That's why these units go back to back. In what ways do our experiences depend on biological processes? We talked about the brain last week or last unit. And you know that there's certain lobes in the brain that interpret sensory information. So to what extent do our experience depend on the brain's interpretation of it? And we're going to find that the brain's interpretation is not sensation, it's perception. So let's get into the nature of sensation. We need to establish what it is. I want you to go beyond your five senses. This is the experience of sensory stimulation, okay? Sensation occurs when energy from an external or internal source stimulates a receptor cell in one or more sense organs. We're experiencing our senses, and there's more than just your five. They're experiencing some sort of energy, whether it be air molecules, whether it be a smell, okay? And then we have these receptor cells, and they're specialized cells that respond to that particular type of energy. Right now, I see the yellow and the orange on the screen. Those are the receptor cells in my retina responding to that color, acknowledging that color. This is what happens. There's energy in the environment, like, let's just say, if we're going to look into auditory. So a type of energy could be a sound wave. This is a vibration of air molecules. When that energy stimulates a receptor cell, which again is that specialized cell designed for that type of energy, a series of dominoes is started. It doesn't mean that the ear, my inner ear, has a little computer in it translating that information. No, what happens is it's neurons firing, sending that message where it needs to go so that that area of my brain can interpret it. Again, sensation, senses, they are just the experience of the sensory information, the sensory stimulation. If you remember in chapter 2, it talked about a neuron firing. There's an all or nothing potential, all or none potential. There needs to be sufficient energy to alert the brain of the sensory experience. How much is needed? If I want to wake someone up, okay, how much sound do I need to make to alert them so that the sound goes across it hits that receptor cell and it says, "Oh, I'm going to fire," so that this eventually gets to the area of the brain that says, "There's a noise. Wake up, that's your alarm clock." And you'll have to forgive, unfortunately, this slide has these reversed. So I want to start with, how do you get that neuron to fire? Again, there's the all or none law in place. There's what's called an absolute threshold, and this is the least amount of energy detected as a stimulus 50% of the time presented. So let's break it down because that sounds way too complicated. 1 out of 2 times when your alarm clock goes off at a certain volume, you hear it and you wake up. So 1 out of 2 times. Maybe you set it a little bit higher, so it's all the time that you wake up. I have a tendency apparently not to hear the alarm clock, but there's times that I do. There's times where it crosses that absolute threshold. If energy does not cross that absolute threshold, it's not detected. So you don't have a sensation, because that would have to be sensory stimulation. It was just something across the blurb that you did not notice. If you go to page 82 in your book, there's a listing of approximate absolute thresholds under ideal circumstances. So how much sound is needed, how much light is needed. Yet what about changes in stimulus? And this is what's on your screen. Have you ever watched a movie that goes too quiet after a very loud scene? I think about Born Identity had a lot of scenes like that. As I remember it, loud car chases, and then it would get quiet. And I would always find myself reaching for the remote to turn it up. How soon do you notice the difference? Okay, now it's loud enough. I can hear it now. How much louder do you need it? The difference threshold is the smallest change in stimulation that can be detected 50% of the time. Again, 1 out of 2 trials, you detect that change. Okay? It varies according to strength or intensity of the original stimulus. It varies. Now, there are for the difference threshold on page 82, there is how much change is typically required. And then there's more information. I'm not going to go into it anymore. You can read about that in your book. If you're interested in taking notes on the absolute threshold, I would encourage that for your midterm. You can pause this YouTube video now and write this down. Adaptation is an adjustment of the senses to the level of stimulation they are receiving. Have you ever found yourself more or less vulnerable to stimuli? Like a loud noise at a circus doesn't really seem that loud because everything else is loud. But yet if you're in a quiet place, like say you're in a study hall, and somebody drops a book, it's incredibly loud. Adaptation, again, is this adjustment of the senses to the level of stimulation you're receiving. We're going to discuss the principle with each sense that we discuss. Just think of it as adapting to the environment. You change your expectations and your experience changes. Now, sensation is much more biological than it is psychological, for the record, in my opinion. But you still want to think about it as adapting to the environment. But this is the automatic process that your senses do. For the record, I'm not honestly sure why the book manufacturer put the picture of this dude on your screen. I'm not sure if they were trying to they were implying that over time one adapts to pain of getting tattoos. I'm not going to take it off. I didn't find a reference in your text, but I thought he was kind of cool looking, so I left him on there. Before we go much further, because we are going to start to go into the individual senses, did you see that flip across the bottom of your screen? It said eat popcorn. Have you ever heard of songs or TV shows having subliminal messages in order to influence the consumer to do something? Beyond the conspiracy theory that lies, there are some messages and marketing strategies to cause behaviors through stimuli that is outside of conscious awareness. There's the definition on your screen. So subliminal stimuli is stimuli below the level of conscious awareness. The reason that they eat popcorn flicked across your screen is because in the 1960s, I believe, there was a gentleman there was a marketing strategy at the beginning of movies that would happen, and all of a sudden, allegedly, more people would go to eat popcorn. The research, and this is important to note for your worksheet, the research says that that's not true. There's not a huge, at least this is what your book says, there's not a huge impact outside of a laboratory. However, as you can read from the research study in your book, there is an impact that tends to happen within a research setting. So please go ahead and look at that if you're interested. But note that subliminal messages outside of the laboratory have no significant effect on behavior per research. But in a laboratory, they tend to process it and respond to the information presented. Let's get into vision. Page 85 goes through how the visual system works. Here's a diagram on your screen of the parts of the eyeball. It's pretty neat to look at. It's pretty neat to gain understanding of how your eye works and how your body works. I'm not going to go through each of the parts. You can certainly look through it. I'm sure for any of y'all that are in allied health, it'll be a review. The basic gist of it is that light enters the eye through our cornea, and it passes through our pupil, and it's focused by the lens onto the retina. And the retina is important because this lining of the back of our eyeball is the one with our receptor cells. And the receptor cells, as you remember, are important because they're the ones that decide whether to send the message up the chain that this information is being received. So you can see there where the different parts are. You can see the optic nerve is there. I want to note that the receptor cells in the retina are sensitive to visible light only. And your book goes through a lot more information about visible light. We're not going to take the time in this course. And then you can see that a little closer where the cornea is. And that's your protective covering over your eye, where the lens is. And then again. So you have two different types of receptor cells in the eyeball. You have the cones and you have the rod. Excuse me. These are two different receptor cells in the retina area. And I think it's foria, but I could be wrong about how to pronounce that second piece. The rods and the cones are the receptor cells. They have very different roles. The cones are for day vision. They're for color, whereas the rods are for your night vision, the light and the dark. So you see that difference? Cones are for color and for your day vision, where rods are for night vision and the light and the dark. Summary table, as you can see here, of the features, the functions, the locations, and the connections. And if you want to study that further, you can be my guest. We're not going to take the time in this course. I want you to know that the rods and the cones are the receptor cells. They're in the retina area, and that the rods are responsible for night vision, for the light and the dark, and cones are responsible for day vision, the color. Let's talk about adaptation for our eyes. Our eyes adjust to different levels of stimulation based on the sensitivity of our rods and our cones. Adaptation is this process by which our senses adjust to the different levels of stimulation. So, as we have the sensitivity for our rods and our cones, it changes based on how much light is available. If you walk into a dark theater on a bright sunny day, so you're outside in the sunshine and you go into the movies, your eyes are going to take a couple minutes to adjust. That adjusting is the adaptation of our vision, of our senses. Your book goes through dark adaptation. This is increased sensitivity in the dark, and light adaptation, decreased sensitivity. Does that make sense? So I become less sensitive because, you know, when you're facing that night vision, you have to really hone in on the details. So it's all fine and dandy for you to have eyeballs that collect information in your retina. However, it wouldn't do you any good if that's where it stops. And now the screen's going on without me having a chance to fully talk, and I apologize. It talks about in your book how the rods and cones are connected to these cells, and they hook up with other cells, okay, who then, the axons, join together and form the optic nerve. What does the optic nerve do? It carries the messages to the brain. Do you hear that there's lots of connections? You should know when you studied neurons that there's the dendrite and the axon, and that the whole purpose of a neuron is to send a message, is to send that signal once there's enough energy. So information is taken in by the rods and the cones, which are the receptive cells. They're connected to other cells, which eventually make the optic nerve, sending the message to the brain. Please note that there is this crossover of the optic nerve in what's called the optic as I was saying, the optic nerves cross over in what's called the optic chiasm, and some of the information eventually makes it to the occipital lobe, but not all of it does. The occipital lobe, as you learned last week, is for the registration of the information and for the interpretation of it. So what about optical illusions? What is that all about? And I have a video that's pretty fun for you guys for that. If that video didn't work for you, I'm going to upload the list so you can have it. For the record, that video, I struggled with the placement of it because I want to start the conversation about color. I want to talk about optical illusions, but it certainly references a lot of topics that they're going to be referenced throughout this unit. So just keep that in mind. And also that spinning diamond, there's also what's called the spinning dancer, and you can watch, there's a resource for that for you on the resource folder. See pages 89 through 91 on color, discussing hues, which is the aspects of color responding to names like red, green, and blue. It talks about saturation, how vivid or how rich that hue is. You're going to saturate it. It talks about brightness, how close to white as opposed to black. We see 150 hues, they say, but because of saturation and brightness, we are able to see 2 million or more colors. The next video shows an artist using a device similar to the one that Bu discussed to help overcome color blindness. If you are studying photography, marketing, graphic design, either you already know about hues, saturation, or brightness, or you need to know about it. Check out 89 through 91. I'm not going to stress or talk about it anymore outside of Neil's video. Hopefully that video worked for you as well. If it didn't, you may check out the videos on Blackboard. Let's transition into hearing. Sound is a psychological experience created by the brain in response to changes in air pressure that are received by the auditory system. It's our brain's interpretation of the sensory information from the ear's receptor cells of vibration. Sound waves, which are essentially what's going across your screen, are changes in pressure caused when molecules of air fluid collide with one another and then move apart again. How they're formed is reviewed on page 91. I'm not going to go through that. It's reviewed on 93, and I'm not going to go through it. You can do that if you're interested. Frequency is how many waves per second. I remember studying this in science, and I appreciate where they're coming from. This biological experience, a very well-tested scientific knowledge. So if you're interested, if you don't remember that from your lower level classes, please go check that out. Pitch is the auditory experience, and here's where psychology comes in, corresponding primarily to frequency of sound vibration, resulting in higher or lower tone. So an amplifier, if you're familiar, causes sound to be louder, essentially. If you want to argue with me in the chit chat, that's fine. Or set me straight, I should say. It's an amplitude is the magnitude of a wave. So how loud is it? Volume goes from soft to loud. There's decibels. All that is further explained in your book, and you can read about that. Decibels is a unit of measurement for the loudness of sound. If you have a nice sound system, you turn it up, you can see how many decibels. It's interesting, as we get older, we often lose the ability, the biological ability to hear soft sounds. We don't tend to lose the ability for loud sounds. Hearing loss is an important discussion though, and we're going to get into that. How does the ear work? Again, I'm not going to spend the time to fully explain it, but essentially sound waves gathered by the outer ear are passed to the eardrum, causing by it to vibrate. The vibration of the eardrum causes these three little bones, as you see on your screen, to hit one another in an order, and that amplifies and carries these vibrations to this window, the oval window there, as you see on your screen, and onto the fluid in the inner ear. Once in the inner ear, the movement stimulates the sensory receptors in what's called, hopefully I pronounce this right, the organ of Corti. And this stimulation of the hair cells produces auditory signals that travels to the brain through the auditory nerve. Do you see that? Do you see that auditory nerve? So it goes from our outer ear to the middle ear where those three little bones are hit in sequence. They amplify the sound, and then it travels a little bit further to the receptor cells in the organ of Corti. And then that stimulation of the hair cells produces auditory signals that eventually travel to through the auditory nerve to the brain. Ultimately, the destination is the temporal lobe, but there are some areas that get messages from this as well. The screen just further shows how the bones are hit. There's approximately 28 million Americans with some form of hearing loss. Did you know that 10 million of those cases are a result of exposure to noise? Top 3 culprits of that are not rock concerts. It's leaf blowers and chainsaws, basically loud equipment. If you're operating equipment at home, it's wise to use earplugs during this so you can avoid hearing loss, so you can continue to fully experience life as it is in front of you. Now there's ways to treat deafness. You can do hearing aid or surgeries or implants. However, it's interesting, in your book on page 97, there's a counter argument to whether to intervene or not if a child is facing deafness. I encourage you to read it. The National Association of the Deaf argues that surgical procedures only partly restore hearing, so it might not be ultimately beneficial. Do you believe that the intervention should be done after reading that? What do you think? There's another type of hearing disorder as well, and this is a steady high-pitched hum, and it's 1 out of 8 people. And it's interesting because there can be, I get annoyed by that sound that you can tell that a TV is on. And I would assume that that would be a similar sensation. So there are treatments like drug therapies, white noise implants, and biofeedback. There are other senses. If you're thinking, let's see, we covered eyes, ears, so you gotta cover mouth, nose, and touch. And there's actually 2 more we're gonna cover besides that. How humans smell remains an open question. We have 12 million odor detecting cells in the nasal cavity. They're pretty high up. They respond only to some of these like odor molecules, sending message to the olfactory bulb and then to the cortex, then to the temporal lobes, where we're able to recognize and remember about 10,000 different smells. How the message from the nose results in the sensation of smell is a mystery that scientists, psychologists are still working on. But you can see the process that's understood on your screen so that you know. It's kind of interesting because odor sensitivity is related to gender and age. Women tend to smell better than men. It's one thing I can say that I do better than my husband, allegedly. And then adults aged 20 through 40, they also tend to have the best sense of smell. And we're unlike other mammals that tend to rely more on our sense of smell. There's a discussion in the book about animals relying on that sense and how it's more keen. Pheromones, which is a very interesting discussion that you're going to have to go through in your worksheet, are these chemicals that communicate information to other organisms through smell. Your textbook has a very interesting review of research on how pheromones allegedly influence human behavior and may influence sexual orientation. I want you to read it, I want you to consider it, and then you're going to work through in your worksheet your thoughts about it. Adaptation occurs with smell as well. If you've ever, I grew up on the eastern shore of Maryland where there were chicken farms, and I didn't really notice the smell because that's what I was used to. But then when I would have people from out of state, they would comment about it. Adaptation happens. We don't pick up on it as quickly. We also have taste, and this is sensory qualities of sweet, sour, salty, bitter, and the sensitivity to MSG. Flavor is taste and smell combined. You ever pinch your nose and try to eat? You don't get the full experience. Isn't that interesting how that works? And is that the full experience as in the full sensory stimulation or the full perception? I would say it's a combination of both. Okay, here, know this for your test because I want to make sure you walk away with something from this unit. Our taste buds are not the little bumps on our tongue, okay? Those aren't taste buds. Taste buds are embedded below, okay? Please remember that. All areas of the tongue can distinguish all taste qualities. Some areas are more sensitive to certain than others. You can see on the tongue as depicted on your screen, sweet in the front, salty in the middle, sour in the back, bitter in the back. The sensation of taste occurs when the chemical substances in the food we eat comes in contact with the taste buds, which are embedded in our tongue. The taste buds then release a neurotransmitter. Oh, so you mean that taste buds are the receptor cells of the mouth. That's what I'm saying. It'll cause adjacent neurons to fire, sending this nerve impulse to the perceptual lobe of the brain and to the limbic system. We have adaptation that occurs with taste. If I were to give you sugar water, and there's actually an exercise in the instructor's manual, if we met as a class, I were to give you sugar water, and then I were to give you straight water, surprisingly the straight water would taste salty, according to the instructor's manual. We adapt to what we expect, we adapt, we adapt with all of our senses, and taste is not excluded from it. Then we also have the senses that come along with movement. Kinesthetic is our muscle movement, our posture. It's also strain on the muscles and joints. For those of you that are going to be OTAs, both of these senses should be very familiar to you. Receptors provide constant feedback from the stretching and contracting of our muscles for the kinesthetic senses. It travels, the receptor cells provide this feedback through information that travels via the spinal cord to the perceptual lobe. This is the same area of the brain that perceives the sense of touch, which we're going to talk about as well. Vestibular, and I think I said that correctly, sense, is a sense of equilibrium and body position in space. The next time you say to somebody, I don't know what ends up, you're talking about, if you're actually talking about a physical sensation of vestibular, what end is up, which end is down. You see a young man on your screen, or at least he looks young to me. And which end is up, which end is down? He's using both of his senses in order to figure it out. The vestibular sense, it originates in our inner ear, where the impulses from our hair cells travels to the brain along the auditory nerve. Some messages from the vestibular sense go to the cerebellum, which is involved in our reflexes, our coordinated movement, while others go to the perceptual lobe for analysis and response. We need to talk about touch. Your elementary school teacher would not let me do this without talking about it, so we covered all 5 senses in addition to 2 more, but it's so important. Our skin is the largest sense organ. We have so many. I mean, it's not like we have 21 square feet for everyone, because it depends on your height and your weight and stretching, so on and so forth. But it's so large. There's so many opportunities for sensory information. You're wearing socks right now. You are touching the floor right now. You're wearing jeans. You're tapping your knee. Those are all tapping into this. The skin's nerve receptors send nerve fibers to the brain via 2 routes. And the eventual, you're going for the sensory cortex or for the RF. Okay? Some information is sent to it so that it will end up at the perceptual lobe. Other information is responsible for arousal of the nervous system. Someone grabs your arm. Would you not want your sympathetic division of your nervous system to engage? Somebody grabs your arm from behind. I want my fight or flight to engage. Skin is responsible for this. Skin receptors also contribute to the sensation of pressure. You see a girl on, it looks like a female, on your screen. Somebody is giving her, or him, I'm just going to say her, for the point of illustration, a massage and applying pressure. You also feel temperature, hot, cold, warm, lukewarm, whatever it's playing into. And then you feel pain. Someone is to pinch you, you're going to feel that because of skin. The skin senses are particularly sensitive, especially on the face or fingertips. Touch is a really important factor in human interaction and emotional expression and emotional experience. The way someone grabs your shoulder might indicate how you feel about it. And that's because, let's say somebody grabs your shoulder kind of firmly, not I would say not threatening, but grabs it in a firm way. It might remind you, like, I'm in trouble. It reminds you of your pop-up because he always used to do that and you love that. Your interpretation isn't sensation. That's perception. It would be terrible of me to not cover pain while we're here. And the reason why is because skin is responsible for that sensation, but pain is such a mystery to us. It's incredibly expensive. It's a division of healthcare that's doing very well because lots of people visit doctors for this experience of pain. I've heard people saying no pain, no gain. It's all in your head. I can use alternative treatments like hypnosis to get over it, or acupuncture, and those might be true. The problem is that psychologists and those in the sciences, they're not quite sure about the nature of pain. They know it happens, people experience it differently, so it's not a sensation, it is a perception, or plays into perception. The gate control theory says there's a neurological gate in the spinal cord that controls the transmission of pain messages to the brain. So if this gate is open, we experience more pain than when it's closed. So know for your midterm that there's this gate allegedly by the gate control theory. If it's open, we experience more pain. Then you have the biopsychosocial theory, and you're going to find that we reference this quite a bit. So there's biological mechanisms that are involved into which tissue was injured, our pain pathways have adapted. So remember with neuroplasticity, we have these neural pathways in our brain. Well, we have one created for pain, just like we have one created for pleasure. So these are biological mechanisms. Genetics seem to play a role also in pain sensitivity. You hear people talk about a low pain threshold. They might talk about their mom having a low pain threshold, and they're not off base from what science is saying. There's also psychological, the psycho in this theory, mechanisms such as thoughts, beliefs, emotion that affect our experience of pain. Have you ever been distracted by something and then you look down and you're like, oh, I'm bleeding? Where otherwise you might get a paper cut and you're like, oh, that really hurts. Isn't it interesting the difference? And that's playing into our thoughts, our emotions. It's also our beliefs. The book says the amount of pain people expect to feel is predictive of how much pain they actually perceive. And perceive is the key word, not sense, perceive. The ability to cope with pain also mediates the perception of pain. How do I expect to deal with the pain of childbirth? I'll tell you what, interestingly enough, I was bound and determined to get an epidural with my son. I did, and I probably could have pushed through the pain. I really think I could have. But I was bent on it, so the fact that I was having contractions, I wasn't allowing for those alternative ways to deal with the pain to enter into my mind. Social mechanisms are the degree of family support that can influence pain perception. Those who, interestingly, have higher family support perceive lower pain, less reliance on medication, and greater activity levels. Family support is a protective factor. There's a concept called resiliency, and family support, supportive network. It doesn't have to be just family. It can be your supportive network, can help you mitigate pain and other of life's woes. There's alternative treatments. Your book goes into it. I'm not going to take the time. Let's get to perception. Finally. Perception is defined as the brain's interpretation of sensory information so as to give it meaning. This is all about organizing and making it make sense. Gestalt researchers wanted to research this further. The history of Gestalt psychologists, it's available for you in your resource folder. I'm not going to go through it. There's a lot more explanation about their principles than I'm going to go through, or your book even goes through, if you're interested. Perceptual organization, according to Gestalt, is based on this idea. And please, you need to have this as your framework for where we're going. It's this idea, so put a frame around it. I see patterns to whatever I see. They believe that the brain tries to create a coherent perceptual experience that is more than simply the sum of all the available sensory information. And that is that it's done in predictable ways. So the whole is greater than the sum of its parts is a quote that's often attributed to Gestalt. It appears to be much earlier than Gestalt, but what we perceive, that overall understanding, is a lot more than just the pieces together. 1 + 1 + 1. Okay, that if I just looked at all the ones, I'm going to feel differently about that if I were to look at it all together. So let's break down some of the principles for you. One of the most basic perceptual processes is distinguishing the object of one's attention, which is the figure, versus the background, which is called the grounds, and it's called figure and grounds. There's a video about attention at the end of this PowerPoint because attention plays into perception. You're going to see in your book, when it talks about this principle, there's a picture of a Dalmatian. I didn't notice the Dalmatian until I read the caption. And that's because the Dalmatian does not stand out from its background. The figure must be noticeable enough to draw our attention. If you look at figures 3-26 and 3-27, which is the grounds? Which is the figure? What do you focus on? Figures with clear lines, contours, can be perceived in two very different ways. There's also the concept of proximity. When objects are close together, we perceive them together rather than a group. The whole is greater than the sum of its parts. I don't notice 16 dots. I don't think 1 dot, 2 dot. I just see a group of dots in my mind. Maybe you see it differently, but that's what I see. Similarity, this is just an animation showing you that we see it together. We don't see it separately. Similarity is I see 2 green lines and 2 blue lines. Objects that are similar color, size, or shape as perceived as part of a pattern. I don't see 1 blue dot, 1 green dot, 1 blue dot, 1 green dot. I see a blue line, a green line, a blue line, a green line. Maybe your experience is different. Then there's the concept of closure. It's not just talking about breaking up with your boyfriend, okay? The closure is we're inclined to overlook incompleteness in sensory information to perceive a whole object, even if none really exists. What do you see in this? Do you see pie slices taken out of the blue dots? Or do you see a white triangle? Why do you see a white triangle? Why don't you just see Pac-Man's mouth? 3 corners of Pac-Man's mouth and the little Pac-Man symbol. Continuity is items that continue a pattern or direction tend to be grouped together as part of the pattern. Okay. Continuity is, and I like the picture in your book a little bit better than this background, it's items that continue a pattern or direction tend to be grouped together as part of the Perceptual consistency refers to the tendency to perceive objects as relatively stable and unchanging despite changing sensory information. Once we form an idea or a perception of an object, we recognize it from any position, any distance, any illumination. A house looks like a house day or night and from any angle. So there's size consistency. If I view I'm looking at my son's chair right now, it looks a lot smaller when I'm this far away. I'm 10 feet away from it. If I were to get closer, obviously it would be closer and maybe look bigger in my visual input, but I know how big it is no matter how far away I am from it. There's a size consistency, shape. I'm looking at it from a side angle. If I were to look at it head on, I've still formed a stable perception of it, and it doesn't change. Color consistency, it's bright red. There's shadows on it right now though. One of the shadows it's casting over it makes it look like a dark red instead of a bright, it's really bright like fire engine red. If I get closer, if I put that shadow in a different light, it might look bright red again. I'm not going to change my perception that it's a bright red. I want you to know some other rules of perception. They're detailed in the text. I'm not going to go over them in detail, but I want you to know them. Our experience plays into our perception. Our memory plays into our perception. So what happens is that you come up on a scene. Let's say, I mean, I've dealt with a lot of individuals in crisis, mental health crisis typically, and I come up on a scene and I have an experience, except for the very first case, obviously, but there's been like 27 bazillion since then. So I have experience and I'm looking for all the cues from past experience. But it's not just experience doing it, it's memory too. Does that make sense? We talked about neuroplasticity. Our experience creates those grooves, and we tend to fall in their grooves. It's nice because I don't have to reinvent the wheel every time I walk up on that scene. Expectation plays into perception, and I have to be careful as a therapist because say I will notice a facial expression. And this has happened with some of my children that I've worked with on the spectrum, and some of the children I've worked with depression. There's this, what I call dead eyes, this flat effect where somebody doesn't really seem to be feeling anything. And I'll make a joke or something will come up that's sad or happy, and there'll be no change of expression. So if I have an expectation, this is really a common feature for individuals on the spectrum, not that people can't feel emotion that are on the spectrum, nor can they not express it. Some individuals can. It's just that it tends to be a preconceived idea. So if I walk up to one of my kiddos on the spectrum, his eyes look dead, I'm like, hey, what's up? And I don't really ask any questions. We'll come to find out he's upset about X, Y, or Z. But I didn't ask, because even though my sensory input was saying, alert, alert, so-and-so's eyes look dead, my perception said, oh, well, I expect to see that because he's on the spectrum. So I'm not challenging my preconceived ideas. We talked about diversity. We talked about differences between other people. And it's been interesting. These discussion boards have taken that direction. The question always comes up, why do people act the way they do? Perception is a huge key in that. And it's playing off of all of this. Experience and memory and expectations, those all start, in my opinion, before birth. It also goes through in your book, distance and depth are perceived. We judge that. And then movement is also perceived. Go over it. I notice my time here. There's real movement, and then there's apparent movement. There's certain things that we think are moving, but they're actually standing still. The book details why. It's interesting about, there was a video that you saw about optical illusions and visual illusions. Perceptual illusions are stimulus containing misleading cues that gives rise to inaccurate or impossible perceptions. All these are described in your book, but if you take the one on the far right, there's two series of 6 dots. Is the dot in the middle, I'm sorry, 7 dots. There's 2 series of 7 dots. The dot in the middle on both of these, they're actually the same size. They don't look like it because the stimulus is providing misleading cues. There's a lot. Perception is influenced by a lot. Remember, perception is the brain's way of organizing all this raw data. It's influenced by motivation and emotion, and we're going to study them as together. That's why they lump them together. Students often are surprised by that. The whole reason you lump them together is they're both a drive to do something, to act a certain way. It's an act or a desire to do something, to initiate behavior. People's desires, needs, and fears shape their perceptions. Again, with the illustration of somebody putting their hand on your shoulder, you're going to react in a way that reflects your past experiences. Maybe we're going to talk about Maslow's hierarchy of needs. Maybe you're at a very basic level. You don't feel safe. You don't feel okay. You feel like your world is falling out beneath you. How do you deal with it? Your motivation is to get your belly full and to feel safe. Someone putting their hand on your shoulder could be a very dangerous proposition. It might not be, but your motive is to eat. And I know that when I'm hungry, I am a bear. Nobody wants to be around me because I'm focused on that. And honestly, the same sensory information could happen 2 different points, hungry or not, and I would have very different perceptions. Like, for instance, if I am hungry and my husband says something to me, maybe he says, I hope you have dinner ready soon. Well, maybe like tonight I was waiting for something to fall out. I hope you have dinner ready soon. I could perceive it as, you better have dinner ready soon, which he would never talk to me that way. But I could perceive it that way if I'm hungry. I'm very irritable then. Or I could perceive it as, man, he's really looking, I hope you have dinner ready soon. Like he's looking forward to what I made for him or for us, for our family. Maybe I made him his favorite meal and I'm excited to see his reaction. I'm motivated in 2 very different ways. My emotional reaction is 2 very different emotions for the same stimulus. So motivation and emotion doesn't just affect me as an observer on one instance. It affects, like, it doesn't just affect me versus you as far as our perception. It could be me versus me 5 minutes apart. Values also impact our perception. The value that people place on an object can influence their perception of that object. And your book goes into a little more detail. I'm not quite sure where they're driving that train. I do know that if I am at a auction, hopefully this makes sense, but if I'm at an auction and I notice something that I want, like there was a fire engine, an antique fire engine that was miniature, which would be a perfect prop for photos with my son. I noticed that, and as the bidding happens, I tended to overlook the scars on that object because I placed a high value on it. Yet, if I would have regarded it in a store, I still would have had a high value on that, but there was also the interplay of emotion and motivation. People see what they expect to see, and I cannot stress this enough. One's perception is one's reality, and people like to be right. We perceive what we want to see. We expect certain things. That's the whole point of perceptual illusions. And Gestalt therapies of filling in the blank and wanting to make reason out of it. We tend to overlook stimuli that is inconsistent with our expectations. If you've ever given advice to, this is the best example I have of this, if you've ever given advice to a girlfriend or a guy friend about a partner, maybe their partner tends to spend money recklessly, okay? I'm sure this has never been the case with any of your friends' partners, but just pretend this has happened. And you say to the love-struck friend, you say, did you notice how they always seem to be complaining about bills, but they're always buying things and they seem to have new things all the time? They just seem reckless. And the partner, the love-struck partner, just overlooks it. There's a sensory information there. The sensory information is the partner they're in love with shows up with new clothes, new outfits, new purses, new whatever, new cars, always seem to be dropping their credit card for everything, yet then complains about money. But the expectations are, I want this person to be my partner, so I'm not going to see that. And a lot of times we tend to blame people for their perceptions, and that's the whole point of that. One's perception is one's reality. You have to change their perception if possible. And honestly, it's not always possible. I mean, something has to cause them to alter that. to shock them. And it plays on some of these other observer characteristics. Cognitive style, people have a way of dealing with the environment. It affects how you see the world. You have a worldview. The book gives the example of field-dependent individuals tend to perceive the environment as a whole. They don't tend to fixate on individual features or objects in their visual field, whereas field-independent individuals tend to maintain perceptual distinctions among various aspects of their visual environment. It's interesting that cognitive, I think about cognitive styles all the time in my line of work, but isn't it interesting that it can boil down to that as far as how perception is? So you're talking about field-independent individuals tend to maintain those perceptual distinctions. They're very observant. Do you hear that? They're very observant. I don't know if any of you fall into that. Experience and culture, cultural differences cause people to attend to different things when they see the same image. What do you see when you see these couples? What do you think? What do you assume about them? It will be all based on your experience. The guy in the green checkered sweater reminds me of Justin off of American Idol, the very first season. It reminds me of being younger. That's my experience. You might think of him in a completely different way. Cultural differences, a person's attention is drawn towards what's novel, what's new. A person with much experience or expertise in a subject can perceive subtle differences of stimulus versus someone with less expertise. I'm sure no one in here enjoys wine tours. Maybe that's not your thing. Alcohol isn't your thing. But for those who do, when you first start sipping wine or going to wine tastings, they all taste the same unless there's very, very bold differences. But yet, as you become a wine connoisseur, not that I am, but as individuals do, they're able to say, that tastes like it's from, a more of a wood stock, or this type of wood stock, this type of wood barrel. I don't understand how people do that. That's that very distinct taste because of experience. And they might also be a very field-independent individuals that they can keep those perceptual distinctions. Personality impacts you. It impacts your impulse and your perceptions. Personality characteristics can serve to prime individuals or make them more likely to perceive stimuli that are consistent with characteristics of their personality. When we talk about personality, I'm just extroverted. If you haven't already guessed, I like people, I like being around people, I like being attuned to the outside world. So while I'm so busy attuning to you, I'm not so great at attuning to myself or my body experiences. And what's interesting is I have friends that are very introverted. I enjoy them. I tend to gravitate towards introverted individuals. And my other friends, my friend who is introverted, who openly talks about it, will discuss how she's very attuned to her body experiences. She's very attuned to any sense of pain, she's also very attuned to herself emotionally. So she starts to feel warm. She assumes that she's angry or tired or whatnot. Or I'm just like, oh, I feel warm 3 hours later, and I didn't solve whatever was causing me to feel that way, or wherever I was going with that. It's very interesting because my husband is very observant, and his perception is pretty amazing. And he is introverted, and he's very, for being not extroverted, he's very observant of other people's characteristics. So he'll say to me, Tabatha, your eyes are very blue. You must have not gotten much sleep. Maybe you should go sleep. Because he knows when I don't sleep, I tend to be a little irritable. His personality is very observant to his sensory information. He's very spot on with his perceptions as far as what I would say is a concrete thinker. Whereas I'm very broad in my thinking patterns. I'm very impulsive in my thinking patterns. And we'll talk about rational or irrational individuals when we talk about Carl Jung's personality theory. He says that I'm more irrational. I'm very feeling based, where my husband is very thinking based, very rationally based. So he just connects the dots. Blue eyes equals Tabatha's tired, she needs to go to sleep. And he points that out. That's personality based, that perception. These next two videos are going to help you as you prep for this week's PowerPoint. I do want, or discussion board, excuse me. I do want you to, if you need to, read the notes about what a cocktail party phenomenon is for the first video by Apollo. All right, well, this concludes these two videos. This is the second video. This concludes our PowerPoint. Thank you for your time. Smell and vision are just two of the senses giving us a window on the world, all combined in a rich, mosaic of awareness forming the basis of consciousness. It is sensation that gives us connections both to our own selves and to our surroundings. I think that depicts what sensation does for us. That starts the dominoes. We're going to go into consciousness next week. There are some optional activities for you to do. A lot of them pull off of what you'll do for your worksheet or in the book as well. But PowerPoint might be easier for you to see them in. You can just